All right, for the openers. And this whole semester, the algebra, the work that I'm asking you to do, the math, it picks up a notch. Okay, so if you thought first semester was challenging in terms of the math that we're going to be working on, it's a little more challenging. Okay, so one way that we help with that is don't just go straight to the problem. Okay, read what the problem is saying and come up with a game plan before you even get started. So one thing that I hope you and your group discussed when you saw this, you said, hey, that's an equation. There's no y. There's f of x that replaced the y. And now what this is asking me to do, f of negative 2, that tells me that the x is negative 2. That's really the main thing that you and your group should have identified, is that the x value is negative 2. And that is being communicated to us in this part right here. That tells me x equals negative 2. So if I know that x equals negative 2, that means that I need to replace the negative 2 or the x in the equation with negative 2 and come up with a value for that. So this is 3 times negative 2 plus 5 and then minus 2. That's the one thing that all of us should have been able to pick up. Now, what we do from here is order of operations. This is where we might have made some mistakes, and that's okay. Okay, but I hope that at the very least we know what this was communicating for us to do, and that's to plug in negative 2 for x. So remember, our order of operations, we think of it as gems. So starting with grouping symbols. Yes, you can distribute, but I'm going to simplify what's inside those grouping symbols first. So negative 2 plus 5, that's 3. So then, if I have a number outside of parentheses, that's multiplication. So I did my grouping symbols. I don't have any exponents. Now I'm on the multiplication, where I'm going to do 3 times 3, which is 9. And then 9 minus 2 gets me to 7. So f of negative 2, that equals 7. So when x is negative 2, we get a y value of 7. Or if there's an input of negative 2, the output is 7. All right, b is the exact same starting point. Replace the x with negative 5. So x equals negative 5. So I'm going to rewrite that whole equation. And I go through gems again. So grouping symbols, those are now the absolute value brackets. I've got to simplify what's inside that first. So that's negative 8. Then I need to take the absolute value of negative 8. And taking the absolute value means to make it positive. So this is negative 2 times positive 8 and then plus 8. So I've dealt with the grouping symbols. Once again, there aren't any exponents. So now I'm on to multiplication. The number outside of parentheses is implying multiplication. So negative 2 times 8 is negative 16. And negative 16 plus 8 is negative 8. So g of negative 5 is equal to negative 8. Or when the input is negative 5, the output is negative 8. This is our lesson today. And we have actually done this exact same lesson before. Where we're kind of adding on to it and what our next lesson, our whole unit is going to be on is graphing. Okay, and more specifically, we're graphing lines in our next lesson. So starting tomorrow, we're going to work specifically on graphing linear functions. For today, we're going to graph with the table of values. Okay, so we're going to evaluate functions at several different values. We have done this before. Then we're going to plot the points on the graph to ultimately come up with the graph of the function. Once we graph, then we're going to also state the function's domain and range. And for today, we're only going to focus on 2 types of functions. We're going to split this up into 2. So we're going to do linear and quadratic functions today. And that's another thing I want us to add into this is identifying the type of function. So number 1, what type of function is this? This could have been a question pulled off your final. Do you see this equation right here? What kind of equation is that? Somebody have a guess? Somebody, what? Yeah, that's a linear function. Let's make a note of that. Oh, you're good. Thank you for participating. It's linear. How do we know it's linear? Well, there's just a variable x. There's no absolute value brackets. There's no exponents. Okay, it is just a basic linear function. Okay, and that's something we want to tie into everything we do. So now our task is going to be to plug in x values and come up with y's. So there's not a ton of space. If you need a blank sheet of paper to do this, that's fine. You can work like in the margins as well, since there isn't a ton of space here. But we're going to figure out what is y when I have 3/5 times negative 10 minus 4. I am okay with you using a calculator here. Now, when we don't use a calculator, I would make negative 10 a fraction by putting it over 1. Then, to multiply the fractions, I multiply the tops together. So 3 times negative 10, that's negative 30. And then divided by 5 times 1, so divided by 5. And then we need to subtract 4 from whatever that equals. So then negative 30 divided by 5, that's negative 6. So y equals negative 6 minus 4, which gives me y equal to negative 10. So when x is negative 10, y is also negative 10. So the first point we're going to plot is negative 10 comma negative 10. So that's left 10 and then down 10, which is slightly off the graph here. All right, and then here's how we're going to find the rest of the values. I'm going to assign one x value to each group. You need to all agree on a y value, and then we're going to come up with this together. One person from each group is going to share what they get. Here are all the values you should have gotten. Okay, I didn't show work. Again, I know there's not a lot of space. On the homework, you have a lot more space. Yeah, you should have shown some work, yeah. But a lot of with these, and something that I absolutely want us working on is identifying a pattern. The x values are going up by how much? James, you had the y's, but the x's are going up by how much? X's, 5, and the y's are going up by 3. Okay, once you recognize that, okay, that can allow you to fill these values in a little bit quicker. And that's also identifying a property of linear functions. They increase by a constant rate. Okay, so now, domain and range, we did this first semester. Remember that domain are the x values, and the range are the y values. So this graph, the arrow is telling me that this line is going all the way left to negative infinity. So the domain is negative infinity, and then all the way to the right to positive infinity. Same thing with the range. This goes all the way down to negative infinity, and it goes all the way right to positive infinity. And we're done there. All right, go and flip this page over. After you have everything down here, we're going to work through one more function today, the quadratic. And we'll save absolute value and, what was the other one, exponential? Yeah. Exponential one ends up being a little tricky. All right, so let's do one of these values together. And I basically told us what type of function this is already, but this is quadratic. Looking at this equation, how do I know it's a quadratic? The exponent of 2. Okay, yeah, that's exactly right. Okay, your quadratic, it's a quadratic equation because the exponent of 2. Shh. Okay, and that's a really important piece for us to pick up on. Every equation, you should be able to identify what it is just by looking at the equation. So now, the task is the same. Plug in x, so y equals negative, and then this is a negative 4 plus 2 squared and plus 4. So now the order of operations is slightly different. Okay, going through GEMS, we do the grouping symbol first. So negative 4 plus 2, that's negative 2, and it's still being squared, and plus 4. So negative 2 squared, that means negative 2 times negative 2. That's a positive 4. That has to happen before we multiply. When we think about GEMS, that's the e, the exponent part. Then this number, or that negative in front of the negative 2 squared, it technically multiplies this 4 to make it a -4 plus 4, and -4 plus 4 is 0. So this first point here is -4, comma 0. Okay, all that work was just for -4. Okay, since there wasn't a lot of space, I went into that next box. And just like before, I'm going to come around and assign each group one value to plug in. Values that you should have gotten. When you plug in -3, you should be getting a y value of +3. When you plug in -2, you get a y value of +4. And then it basically is symmetrical, so we get the same points from there. When you plug in -1, you get a y value of 3. When you plug in 0, you get a y value of 0. Then when we connect our points, we should know what a quadratic graph looks like. It's that U shape. In this case, it's an upside down U, so kind of like an N, a lowercase n. And now let's just describe domain and range. I'll be all done. So domain here. Remember, this arrow is pointing that it's going all the way to the left to -infinity. The other arrow, yeah, that one's perfect. Actually, yeah, I'm going to go with this one. Coach Mack, you're the best. Thank you. Thank you. I appreciate it. All right, then the right branch going all the way to +infinity. Shh, we're almost done. And last thing, the range. Okay, eyes, ears up here, please. This is one place where a lot of students make mistakes. Remember, with interval notation, we start with the smallest value, which in this case is how far down the graph goes. This graph goes all the way down to -infinity. And the highest up it gets to is this y value at +4. Okay, so it's -infinity all the way up to 4, and we use a squared bracket at 4 because that is actually part of the graph. Okay, we're going to stop with those two functions. We'll do the absolute value and exponentials next time.